In the next video, we will talk about the development of domain-specific language by using the Xtext framework. In the first part of the video, we'll describe some general concepts related to a topic and Xtext itself, and we will see what is Xtext and which are the main features. Besides this, in a second part of the video, we'll describe step-to-step of a case study to create a domain-specific language focused on the modeling process. Obviously, we will use Xtext to relate this. We will describe what grammar is defined. We will see an example of using of the language, and we will see how to build artifacts with expand templates. Thirdly, we will see how to build XML from our new specific language. Nowadays, there are languages like Java, C#, Python that are classified as a general purpose language, but there are other more specific kind of language, now as domain-specific language, we are used to. These languages are dedicated to a particular problem domain or a particular problem representation. Some examples of domain-specific language are R and C language for statics, Mata for matrix programming, SQL for relational database queries, or etc. In our case, we will create a new domain-specific language like GPDL that allows us to model business process. We will use Xtext, which according to wiki.dev Eclipse, Xtext is a framework tool from development of external textual DSL. This framework is integrated with technologies from Eclipse modeling such as ENF, GNF, M2T, and part of EMFT. Some of these main features are syntax highlighting, code completion, validation, and query physics integrated with ENF, as mentioned above. Okay, now we are ready for seeing a case study where we use all this. Now we begin the definition of grammar for generating our DSL. Before this, we have created a new project Xtext which has generated 3 different projects. One of them will be used to define the grammar, another is the template generated artifacts, and the latter will allow us to create a plugin for using our new language. Well, in the central part of the window, we can see the grammar that defines our DSL. It identifies several statements that define our language. For example, this one. Define the star entity with its relationship with transition and properties. The same goes for tags, statements, decisions, fork, etc. Once created the grammar, we can execute our project to create our new language. After this, we can run our project UI to use our new language on the editor from another instance of Eclipse. After waiting a few seconds, we will have a new instance on which to build project using our language. For this example, this instance has already created a new Java project that contains a file coder of our language. If you look at the center, we see how the language is used to define the traceability process of wine making. This plugin, as discovered above, have syntax highlighting, code completion, and validation and query physics. For the latter case, we have had to add a validation before. This model will be used in the later part of the practice for the generation of artifacts by expand templates. Finally, we have created a template expand that translates code writing on our language to XML. As in the middle, creating a template expand consists of writing code that is generated as a function of each sentence of our language. if we execute the generation project, it will generate the SML template that has been defined and which contains information for traceability of winemaking. We have created a SSLT template that allows to see our file like HTML file more easy to read. That's all. So thanks for your time and have fun.